All right, have a seat. I got this. This is a small update on TinyGo, and I am dead program. Some people call me Ron, a couple humans call me Dad, but that's not important. I am dead program, and I am a technologist for hire. Get it? Technologist for hire? I was told it's good to be subtle. So I run a small consultancy called the Hybrid Group, where we create the software that makes your hardware work. And some of us work on a little project you may have heard of called TinyGo, the Go compiler for small places. So let's talk about some current stats. 16,000 plus stars on GitHub, 950 plus forks, 250 plus contributors of code, over 125 different boards and other hardware devices, over 120 different sensors, actuators, displays, and other devices you would connect to those boards. We just released TinyGo 0.38, a few highlights. Multi-core in hardware. Where's Ika? Like, amazing work. Really remarkable. We also now have USB mass storage device support. So on some devices, you'll be able to stick it in, put files on, and then serve it up right from your board. Ooh. And of course, some cool things in WebAssembly, like adding the new BOEM garbage collector, which is a very, very serious industrial strength garbage collector, adding to the collection of garbage collectors that we have in TinyGo. So weighing in the binary sizes for the latest BigGo, 124.4, and TinyGo 0.38. So first program, hello.go, your basic TinyGo Go program, brings in no external dependencies or packages, just uses printline. So with BigGo, most recent, about 1 megabyte in size. TinyGo, just under 14 kilobytes. All right, pretty good, pretty good. Yeah, you can applaud, because it's 72 times smaller. All right, so that's kind of a trivial example. Let's take something a little more interesting. It brings in the front package, which means it needs reflection. Bring in the OS package. This time, we're going to compile this code for a WebAssembly target with WASI P1, WASI Preview 1. So BigGo, about 2.5 megabytes in size. TinyGo 80K, about 31 times smaller. When we say tiny, we mean like tiny. All right, but it's not all about just size. Let's also about speed, right? So cool project that we've started recently within the TinyGo continuum, started by my colleague Patricio Withingslow and myself, TinyBench. So we're taking benchmarks of Go, TinyGo, GCC, Clang, Zig, and Rust on a few algorithms. So let's take a look at some of the numbers on the latest benchmarks. So this blue line here is BigGo. This green one here is TinyGo. We've got GCC, Clang, Zig, and Rust. And you'll notice that in most of these benchmarks, actually in, I guess all of these benchmarks, TinyGo is faster than BigGo. And in a number of cases, TinyGo is faster than C. So check out these benchmarks, because we'd like you to add more. All right. So the TinyGo, it's all not about just being fast and being small. How do you get started with TinyGo? Well, we have a lot of different resources, and others have created them. Most recently, we've been adding to the TinyGo Tour, which is an online tour that lets you play with virtual machines if you don't have any actual hardware. And we just added the pulse width modulation PWM tour. So you can basically use an actual virtual device, write TinyGo code, and execute it right in your browser. Once you have it working, you can then just download it and flash it right onto a real device. So that's all done with TinyGo and WebAssembly. Lots of cool stuff happening there. Maybe you like books. Well, this is a recent book that just came out from Eleanor, Donia, and Pascal. You may have seen one of Donia's amazing talks about TinyGo, like getting the upper hen, how she automates her hen house. This book just came out on Manning, Learn Go, pocket-sized projects, and it's a really cool book. Lots of cool stuff about TinyGo. Also, the TinyGo Key book. This is a book in Japan put together by one of our team members, Takasago-san, who, in addition to having this book, is organizing the first TinyGo Conf 2025 in Japan, Tokyo, Akihabara, October 12th. Be there. All right. I know, they deserved applause. So TinyGo gets all over the world. This is a recent class. We did it at the University Laboral de Toledo, organized by Danielle and another friend of ours. Got to program the future. Let's talk real quick about WebAssembly. I'm over time, but too late. So welcome Big Go. Big Go now has WebAssembly P1 support for the reactor, so go team. Worth mentioning, TinyGo already has Preview 2 support. We're working on Preview 3. Think of us as like the speedboat and them like, the aircraft carrier. So walk through a Wasm Cloud CRUD application written in, of course, TinyGo from our friends over at Wasm Cloud. Very cool sample application and explanations. Firefly Zero, which is an actual physical game console running WebAssembly that you write the games in WebAssembly. This is a prototype that we saw at FOSDEM. Yes, it has multiplayer mode. You can write your own multiplayer games on physical hardware using TinyGo. Yes, I want one. So this is a little project that I did myself with WebAssembly and computer vision called Wasm Vision. It lets you do everything that you would ever need to do in computer vision and then call it from WebAssembly. This is me with fast neural style transfer applied. Yeah, you can call deep neural networks right from your computer vision code in Wasm Vision. Check that out. So let's get back to the hardware, because it's all about the hardware, right? So golang on the PlayStation 2. This is an absolutely amazing hack. It was on Hackaday. Check it out. There's part 1 and part 2. He's working on part 3 right now. Horde of the Rings. This was using the TinyGo Bluetooth package in order to extract data from the Colmy BLE activity tracker ring. Very, very cool little project. The Eclair M0, which is a very small little notepad built by Mateusz Zoek. I'm probably just butchered your name. Sorry. A very cool little project. Merliel, which is basically an IoT online system that's got built-in machine intelligence created by one of our team members. Very, very cool little project. Check that out. Go Haystack lets you build your own AirTags out of hardware. In fact, GopherBot here is an AirTag. This is me tracking black GopherBot as we cruise around Berlin earlier today. So we've been busy. The TinyGo T-Key1, the Teletas T-Key1 is an FPGA-based USB security token that then runs a soft RISC-V core that you can then compile and run TinyGo programs on in a secure environment. Cool project, check that one out. This is proving TinyGo's air and space superiority once again. Our Patricio Whittingslow, who has done a lot of amazing work in TinyGo, had a great interview on the Fall Through podcast, From TinyGo to Takeoff, loading fuel into highly explosive rockets with Go and, of course, TinyGo. You need TinyGo to go into space. You don't have a lot of weight for payloads, right? The flight head tracker from Yuri, who is here, this is absolutely amazing. You've seen some of his stuff before. Absolutely incredible projects for basically doing real-world airline flight of UAVs and then being able to do head tracking. Here is a recent flight with a little loop-the-loop. Oh yeah, it totally worked. So yeah, if you want to actually check out the physical hardware of this, come tomorrow to our little hack session in the patio. Because we're now coming to TinyGo at GopherCon EU 2025. Oops, my bad. So hardware hack session day 1 was really fantastic. We had lots of cool toys to play with. We flew drones. No humans were hurt or injured. It was absolutely fantastic. We had a great talk yesterday from Ica about multi-core. This was the demo they were trying to show of basically the before and after of the Mandelbrot rendering speed. You can see it got a lot faster when you've got multiple cores. And you are here. We made it. So come to the hardware hack session tomorrow, part 2, 10 a.m. in the courtyard. We've got lots of toys for you to play with, lots of awesome things. And follow us on Mastodon or on Blue Sky. That's where we are now on the socials. tinygo.org. Thank you.